Okay, 5.1 is rational numbers, okay? It is a number that can be written as a quotient. What's quotient mean?
The answer to our division.
Quotient is
As
a,
a quotient of two integers, okay? So you have rational numbers, and it encompasses integers, and it encompasses whole numbers. Okay, rational numbers. So it is a number that can be written as a quotient of two integers. Whole numbers and integers are part of a set of rational numbers.
oh, we're in a new chapter.
Yeah, we're in a new chapter, chapter 5. Okay, so we want to show that the number is rational by writing it as a quotient of two integers. How would I write 7 as a quotient of two integers?
Say it again.
How would you write 7 as a quotient of two integers? Meaning, how do I rewrite that number so that when I divide it, it gives me 7?
Quotient divided by 2.
No, you have to use the number 7.
Oh,
One
7
divided
divided
by
by 47. No,
What'd you say?
49.
7.
Not 1 divided by 7, flip your term.
7 divided by 1.
7 divided by 1. So to write this as a rational number, you would write it as 7 over 1.
Okay, what about 49 divided
We want to use 7 still.
by 7? Okay. What?
So
That is
Okay,
easy.
well,
I know what you're saying, but no. We want to just change what they gave us into fraction form.
Okay.
Okay? So 7 changes into fraction form by putting 7 over 1.
Okay.
Okay? How does negative 10 change into fraction form?
Negative 10 divided by 1.
Yeah, negative 10 over 1. Good. Now, or, so you could write it like this, negative 10 over 1, or you could write it as 10 over negative 1, yes?
Yeah.
Because if
technically
I
the
do
same thing.
right, because they're the same thing, right?
Yeah.
So either way that you write that is acceptable. Cool?
Bushy.
Now, if I have a mixed number, how do I change that into a rational number?
I know.
You'll want to put that into a, what is it,
Mm-hmm.
can't think of it. Gosh.
I know.
I
What?
can't think of the word.
So multiply 5 and 4,
Well,
then add 3.
Yeah, so an improper fraction?
Yes, that's one thing.
Change
Like
it
improper
into-
fraction.
Change them into improper fractions. So what's 5 times 4?
20.
And add 3 and you get
23.
23 over
4.
4. Is that reducible?
No.
So we leave it. Okay.
Oh, this is what we're doing?
Mhm.
Woo! Finally, it's
Wow.
easy.
See how the wording just was confusing at first, but it's really simple. What about negative 3 and 1/2?
Negative 3 times
Times
2, then negative 3 times.
No, negative 3
negative
times 2
6 plus
plus
1.
1.
Okay, so what do you get?
Negative 5.
No.
What?
Oh. Ooh, this is a tricky one. It's not technically plus 1. This whole thing is negative. Negative 3.5, right? So just say 3 times 2 and you get what?
6.
Plus 1 you get.
7.
Now
Oh,
bring
so
the negative
everything.
with it.
So we
Okay,
negative 7.
Okay.
So it would be negative 7 over 2, okay? Because it has to stay negative because the whole thing is negative, okay? So don't get confused about that. Just multiply first, then add, then keep the negative sign. Okay, cool? Thank you. That's what we're looking for, okay? So if they want you to write a rational number using it in quotient of two integers, they want you to change it into a fraction or like into improper fractions essentially, okay? Okay, some definitions first. Terminating decimal, okay? A terminating decimal is where the division ends because you obtain, that should say obtain, I just wrote it close together, a final remainder of 0. Meaning, if I take 12 and I divide it by 6, what do you get?
6. And 2.
2. You get like 2.0, right?
Yeah.
So it's terminating. The decimal is terminating. It stops. Okay? There is no repeating to it. If you take 100 and divide it by 3, what do you get?
I don't know.
Well, figure it out. Wait, what
I
is
don't
it
have a
supposed to say?
calculator.
If you get 100 and divide it by 3, it says obtain. Obtain the final remainder of 0. Yes.
Wouldn't it be something like 3.3 repeated?
Yeah, it's 33.33333 and it repeats. Okay?
I'm doing
If
that.
the decimal repeats or a pattern of decimals repeat, it is called a repeating decimal. Okay? And it is symbolized often by, I thought I wrote it up here at one point. by this, okay? See this bar that's over top of this?
Oh, that means like it's
That's right.
on.
That means that it would repeat, okay? So that bar means that it's a repeating decimal, okay? Does that make sense?
Very good.
So if something is terminating, it stops, it terminates, it ends, okay? And if something's repeating, the decimal has a pattern to it, or it's the same decimal that keeps repeating. So it could be that the decimal goes 0.128, 128, 128, 128, okay, it's got a pattern. Or it could be that it goes 0.111111111, and just keeps going, okay?
Yeah.
Those are what you're looking for. So if I wanna write 3/8 as a decimal, what do you think I need to do?
Divide.
Yes, but can I do that in my head? What type of division do I need to do?
Oh,
What type of division do I need to do?
I don't know actually.
Something from elementary school.
Oh.
Long division?
Long division.
Really?
Yes.
Oh no.
So we're gonna set it up like this. 3 goes inside the division bar, 8's on the outside, and we're gonna keep adding zeros until we get to an answer. So can 8 go into 3?
No.
So 0, right? And then I would subtract, and I bring down the 0, remember this? Can 8 go into 30?
No.
Yeah.
Well, how many times?
No.
It can.
No, no.
3.
3? What's 3 times 8?
3 times
Oh
8
yeah,
is 24.
yeah.
So 3, so you bring 24 here. What's 30 minus 24?
6.
So I add another 0 and I bring it on down, okay? Bring it on back. There's actually a little phrase for this. Bring it on down, bring it on back. Divide. 8 into 60 goes
7.
7 times. Now we multiply. 7
56.
times 8 is
56.
56. Subtract. Bring it on down and bring it on back. Divide.
Oh, that'll be on
4.
5.
5. Multiply. Subtract. Now we have a remainder of
0.
0, so are we good?
Yeah.
Gucci.
So if we write that as a decimal, we get 0.375. I need to see long division on your homework. Understood?
Yes.
Do not plug it in your calculator and give me an answer.
Can we
Because
still
I need, because I
Why?
want to see that you understand how to do
Can we
this.
still use the calculator?
To check?
Yes.
Yes, to check you can, but show me your work.
Okay.
Okay, which means I should have lots of bring it on down and bring it on back up. Okay, 5 divided by 11, how do I set that up?
11 as the outside,
11 is the outside,
then 5 on the inside.
5 on the inside. I'm
Is that
gonna
use
go
denominator?
ahead and put a 0 there. Yes, Gabby?
I can't see.
What do you mean you can't see? You're in the second row.
I need glasses.
Okay, well, I can't get you any closer.
There's like a seat right there.
You can sit next to Bree because Grace is gone, that's as best as I can do.
Okay.
Yeah, but Grace is gone for good, so she can sit in Grace's spot for good if she wants.
Oh.
But I can't get you any closer than that, so.
Yeah, I can see fine.
There's a literal seat. Right
Okay,
I thought you meant.
can 11 go into 5?
No.
No,
Wait.
so bring it on down and bring it on back.
Actually, it can.
What, not
Oh, wait, no,
even-
never mind. Never mind.
Can 11 go into 50?
No, but it can go to 44.
11.
Why'd you put
4.
5?
4.
Oh my.
Why'd I put 5 where, Bree?
And,
It's 5 first.
Because
You
5
drop
minus
it.
0 is 5.
oh.
So multiply by 4. What's 4 multiply? 4 times 11 is?
44.
Okay. Subtract. What do you get?
Oh, 6. What do I know?
Bring it on down. Bring it on back. Divide.
5.
Multiply.
55.
Subtract.
5.
Bring
Oh,
it
no.
on down and bring it on back. Divide.
4.
Multiply.
It's a loop.
Oh, is
Let's
it?
add that weird top line.
Let's
thing.
add that weird top thing on it, is that what you're saying? Okay, so you notice that, let's just double check and make sure that this is 5, which it should be, right, cause this was 50.
Yeah.
Okay, so we multiply by, 5, right? No, not 5. 4. It's 4. Did we do that right?
Yeah.
That's what you get for
4,
trusting
5.
me. No, we didn't. Wait. Yeah, we did. We did it right. We did it right.
Yeah, wait, did I not multiply this one? 4, 5, okay, I didn't multiply yet, that's
Yeah.
why. I just had it written up there.
I said it
Okay.
early.
So then, you get 6 again, right? And
You
I
got
have
it.
to bring it on down and bring it on back again. So yes, this is clearly repeating, yes?
The top line thingy. Yeah.
Okay, so yes, so we would just put that nice little fraction bar. So when I write this answer, I can write it like this, 0.45 with a fraction over that, with a little bar over that part. You have to write it over the part till it repeats. Does that make sense?
Yeah, because then it's gonna like act like if you add another number
Right.
in. Yeah.
So that we can do forever. If you notice there's a pattern, stop, where it starts to repeat and write your answer like this. Okay? So we have a pattern going on there. Cool?
Okay.
Okay. So, don't forget long division. Okay, then we get word problems with fractions.
No.
You've got to be kidding me.
Guys,
Please
these are
stop.
so simple, trust me. Of the 50 mammal species found in Canyonlands National Park, 20 species belong to the rodent, I don't know.
Rodent, yeah.
Yeah. Of the 54 mammal species found in Badlands National Park, 24 belong to the rodent family. In which part is the fraction of mammal species belonging to the rodent greater? What do I need to do? What do you need to do to figure out which one's greater?
50 species in Badlands, the national park that belong to rodents, yeah.
Oh,
So 54 minus 24?
no. Oh, wait, 20. I'm guessing over
Oh, no, it's-
24?
Over what?
24? 20 over 24?
No,
Nope.
it's 50
Oh,
over
wait, do I
54.
flip it? Do you flip it like
Oh, that's
24
right, it's
over 20?
24 over 54.
It's what?
24 over 54.
24 over 54, because the Badlands has 24 belonging to that out of 54. So Badlands is 24 over 54. What about the Canyonlands?
Canyonlands?
Mm-hmm.
Canyonlands. It's 50 over 24. No, 24 over 50.
No, 20 over 50.
20 over
Oh, I
50.
didn't see that part. 20.
Canyonlands is 20 over 50. Now, what do we have to do with those fractions?
Divide by 5.
Nope.
Gives them a equal denominator.
Either get them to an equal denominator or
You good?
change them to decimals. Yeah, or change them to decimals. Let's change them to decimals. If I change this to decimal, I have 20 on the inside, I have 50 on the outside, right? And that would be 0, 0, point.
32.
If I add a 0 there, how many times does 50 go into 20?
Oh,
20?
4.
4. Yeah, so you get 0.4 as your solution there. Now, 54 into 24, yes?
Ew. What was that?
What are you
is
doing?
what?
Ankle bro? What
Did
the
you
heck?
crack your toes? What did you just
So, here we go. What goes, how many times does 54 go into 24?
I have no clue.
Well,
Oh, a calculator.
54 divided by 24. It can't go into 24.
Was
right,
this you
so
screaming
give me a
into
number
rubber?
that gives me
Wait,
close.
wait, I didn't do it right. I did 5.
I heard that.
Hey,
Sorry.
Yeah, it still can't go.
well, what's 54 times 2?
It's 104.
108?
No, 100.
108. What's
Yeah.
54 times 3?
I don't know.
Wait, say it again?
54 times 3?
18. Nope, that's division. 162.
Dang,
What's 54 times 4?
It's 160, right? No, 161.
216.
216. What's 54 times 5?
54 times 5.
270?
Yeah.
So we have to go with 4 because it's 216, it's less than this. So then you do 216, you subtract, this becomes a 3, yes? 3 minus 1 is
2.
2, 10 minus 6 is,
4.
bring it on down, bring it on back. Oh, what do you notice here?
There's a 4.
Look, what number was this? 2, 4, 0. This is,
2, 4, 0.
so what is it gonna be again?
1. No,
4.
I'm stunned.
4, so what's gonna happen with this
It's
decimal?
gonna repeat.
It's gonna repeat. So this answer is 0.4 repeated. So which one is greater? The 0.4 repeated. So the Badlands National Park has a higher ratio of rodent species.
That's That's good.
Okay? That's what they're looking for us to do. Now, write the terminating fraction as a decimal. How would I write 0.07 or 0.7 as a fraction?
It'd be a 17 over 100.
I think I wrote that backwards. That should say write the terminating decimal as a fraction.
Oh.
Little dyslexia kicked in there.
So 7 over 10?
So 7
Yeah.
over 10, yes.
Yeah.
So 7 over 10. How would you write negative 3.05 as a fraction?
You're tripping. Oh no, I know. Negative 3, 5 over 10.
Negative 3, 5 over 10.
Oh, wait.
Mm-mm.
No, isn't it supposed to be like a mixed number?
Oh, it's negative 3, 5 over 100.
Okay, well, let's talk about that. Let's talk about what both of you said.
Okay.
So you said negative 3, 5 over 100, right? Negative 3, 5 over 100. Does 5 over 100 reduce down?
Yeah.
To what?
20, so 1 over 7.
So 1 over 20. Okay, so I can write negative 3 and 1/20th as a solution.
Oh.
Okay. Now listen, I get what you're saying. Shouldn't it be as a improper fraction?
Yeah.
Because we did improper fractions over here.
Yeah.
Yeah, okay? When they are asking you to write something in the quotient of 2 integers, you put it in improper fraction. When they're asking you to change a decimal to a fraction, you can use mixed numbers.
Okay.
Or you could use an improper fraction, I will accept both. Okay? But always reduce your fraction down as low as it goes. Does that make sense? Reduce, reuse, recycle. Okay? Now, this is gonna be the trickiest part, so I need your brains to be open for a minute,
Oh
okay?
gosh.
That's gonna be difficult.
Because you have to do some algebra here, okay?
Oh, no, it's supposed to be.
It says write 0.93 repeated as a fraction. Let x equal 0.93. Now, here's the deal. If this said write 0.93 as a fraction, could we do that?
Yes.
What would it be?
Would it be like so?
Oh,
What would the same
it's
thing I
90.
did there?
Yeah, it would just be 93 over
Okay.
100. Okay, but because this is repeated, I can't just put 93 over 100. Okay, it has that repeat sign. So I have to do some math. Here's what you need to know to do. What place value is that? What's the greatest place value there?
The tens?
Not the tens.
Zero. The
The
decimal.
hundred.
The hundredths is the highest place value that I have. So I need to set up an equation. Do you see how it says x equals 0.93 repeated?
Mm-hmm.
Okay, we're gonna take that and we're going to say, let's go ahead and multiply both sides by 100. So if I take this equation of x equals 0.93 repeated, I wanna take this side and multiply it by 100, and I wanna take this side and multiply it by 100.
How do you do that?
Well, what's 100 times x?
Oh, 100. Oh, 100.
100x. And what is 100 times 0.93 repeated? What do you think that comes out to?
This is where you come in now.
9.30.
How many?
0.
No. How, if it's repeated, what does that mean after that 93?
It would just go back to
just
the
one
bigger
zero
number,
and
which is
90.
93.
So it'd be 93 point,
Oh. 0.
no, point
9.
3. Because what happens when you multiply something by 100, where does this decimal go?
This is
1, 2, right?
yeah.
And what's after that 3 technically?
No.
0.
No. When it has a fraction, when it has a bar over it, it
Repeat,
means
isn't
that it's repeating.
So it'd be a 9 after the 3.
So you have to use your brain here, okay? And you have to say, oh yeah, there's another 9 and a 3 after that. So when I multiply by 100, I have 93.93 still. Okay, do you see that?
Gotcha.
Okay. So you get 100x equals 93.93, okay? Now, that's step 1. Step 2, you want to subtract x, okay, from 100x. So, right now you have this equation, 100x equals 93.93 repeated, yes? Okay, and we want to subtract x from that. What does x equal?
0.93 repeat.
Yes, it equals this. So we're subtracting that. Okay, so we take the equation they gave us and we subtract it from the equation we created. What's 100x minus 1x?
100x minus 1x.
What's 100x
99.
minus 1x?
Oh.
99x.
Oh,
The x's don't cancel. 99x. What is 93.93 repeated minus 0.93 repeated?
93.
93. Now do you see how I got rid of the decimal? Now what do I do to solve for x from
You
here?
wanna divide?
okay.
You would not want to divide. That's step 3. Good. So step 3 is solve for x. So you divide by 99. You get x equals 93 over 99.
You can.
Is that reducible?
I think so.
Okay, what's it reducible to?
3.
Divide by 3?
Yeah.
So 3
So,
goes into this,
31.
31 over,
33.
beautiful. And that is your final solution. So you have to do a little bit of thinking here and you have to do a lot of math. You gotta show me work.
Gotcha.
Because you're starting to set up one-step equations. It is a lot of work.
No, it's not. Actually, yes, it is. What am I talking about? Holy
Okay.
crap.
But listen, I wrote it down in steps for you. So do it in that order. Okay?
I'll remember.
I would copy those steps
I'll make sure
down.
to take a picture.
That's fine, okay? So you multiply both sides by 100 first, from the original equation they gave you. When you do that, you get a new equation of 100x equals 93.93, or if it was 0.47, you would get 47.47, okay? Then you take that equation that we created and you subtract from it the original equation, boom. Your answer on this side should always come out to 99x, I will tell you that right now. Okay, so your final answer should always be over 99 when you're doing them this way. Does that make sense? Okay, if you don't have 99, you did something wrong.
Oh, wait, I've done this before.
You should have done this before.
Yeah, I did.
Did we?
You know, but I did. I remember I did.
Possibly, you should have, technically, in elementary school, you should have.
I don't remember that.
Okay.
Wait, what do you mean?
We didn't do this in elementary
That's
school.
We didn't do this, but we did.
Oh,
the
God, you
one-
saved
Okay.
me.
That's good, that's fine. Now, order the numbers from least to greatest. See all those numbers?
Yes.
Oh, that's kind of easy.
Oh, what do you think I need to do with all those numbers to order them from least to greatest?
Oh,
Just
you need to
leave
put,
them.
oh, I
Solve them
know.
into that.
Just turn it into
Transcementing.
decimal.
That's
Turn all of them into decimals, and then here's the deal though. When you give me your answer from least to greatest, I need them in the form that they're originally in. Okay?
Oh,
What does -5/4 turn into decimal wise?
Technically,
Wouldn't it
Is
make
your-
more sense to turn the decimals into fractions?
Okay, turn the decimals into fractions. What's point?
it's
That's
0.8.
I don't care, what's point
No, it's
two?
8.0.
Stop.
Sorry.
What is -0.2 then, Mia?
When did you?
I
see that
Two?
Isn't it?
1/5?
Negative 2 over
Wouldn't
10.
it be
It's
negative
negative
1/5? Wait,
Negative Stop, I-
0 over 10?
Yes, so then that reduces to?
Negative 1 over 5?
So here's the deal though, look at this, if I change this to a fraction, do these fractions have the same denominators?
No.
No, so that might be why it's easier to change it to a decimal. Does that make sense?
Yeah.
Okay, so my suggestion is just change them to decimals and then put them in the right order with the fractions and decimals already. Because if not, now you're gonna have to do another step of getting common denominators. Okay, so what is 5/4 as a decimal?
I think it's 8.0.
You think it's 8.0?
Yeah.
How did you get a whole number from that?
I don't know.
Do you mean 0.80?
Okay, 0.80.
I'm asking, is that what you mean?
I don't know. I know it has something to do with an 8. That's all.
Which word number?
What is -5/4 as a decimal?
1.2?
It's definitely not a whole number. Oh, yes it is, you're right, 1 point something. 1.25, how about that?
Oh, yeah,
As 1/4,
yeah.
right? -1.25.
It's like 5/4.
It is like 5/4. That's decimal, that's decimal. What's -3 is, -3 we can figure out, right? Cause it's like 3.0, okay? What's 5 seconds?
5 seconds.
2, 4. 2 and a
2.5.
And what is negative 13/3? 3, 6, 9, 12.
D2.
4 and 1/4.
4 and 1/3. Okay, negative 4 and a third. Now, this should be easy. Or, let's go ahead and put this on a number line to make it a little easier.
Yeah, I've seen it. Wait, least to greatest, that means from negative to positive.
Uh-huh. So, let's go. What's the, what is your least number right now?
It's negative 0. No, it
Negative
is
3.
negative,
Not negative 3.
yes it is.
Negative 4.
It's this one. See?
Yeah, negative 4, sorry.
So we're gonna go negative 13/3, which is negative 4 and a third. So right about here, and we'll say negative 13/3. Okay? Now what?
And
2, what are the
What's
two?
your next least?
The next list is
Negative
1,
three.
negative 1.2.
Negative 3. Okay? What's your next least?
Negative 1.25.
Negative 1.25.
That's kind of confusing when you.
Or negative 5/4, right? We're gonna change it back, negative 1.25, so. I know, but you're gonna have to start thinking this way. Now what's your least?
0.2.
Negative 0.2.
And
I think that's
4.1.
And then what?
And 4.31.
No,
Oh,
that's not
there's
positive.
that one, yes, haha, I forgot about that one.
5
Five.
seconds or 2.5, right?
Forgot about that one.
And then 4.31, yes?
I forgot about that one.
Least to greatest, okay? So that's how you're going to do this on your homework.
Yeah.
From fraction to division.
You don't have to do a number line, I just put on a number line because I think it's easier to visualize, okay? But you could have written it this way, because it said least to greatest, you could have just labeled it like this.
So yeah, when you're doing a fraction, you have to divide by it.
So I want you to keep it in the original form, because in your book, they're gonna give you the answers with the original form. Okay, so you can change it with a calculator into decimals, which is fine, but make sure you write the original form when you're giving me your answer,
Okay.
okay? That is what this whole section is about, and that's probably the longest lesson we've ever had in this class.
It is?
Mm-hmm.
We did a lot.